Alright, gestures come up a lot these days in GUIs, graphical user interfaces, and the way that's usually done is with a motion tracking system, usually on a per pixel or a per coordinate level. So the easiest way to do that in Altia design is to set up motion tracking in two different directions, on the x-axis and the y-axis. This sets up the ability for you to move around the screen, whether it's touch screen or with a mouse, and actually record what coordinate you pressed and release the mouse button, so that your logic can take care of things like, okay, what was the delta between the press and the release, and what was the time between the press and the release? Was that a fling, or am I still scrolling? All of that is on the logical end. But to track that motion, to get those coordinates, you need a coordinate tracking system, and that's done with Altia Stimulus. So let's just start by drawing a rectangle. You could do this on a background image or some other object, but for the sake of this demonstration, a rectangle will serve us just fine. I'm going to add stimulus, so the first thing I do is group it. Just like with animation, you want to always group first. And what I'm going to do here is actually create tall, skinny rectangles on each side and interpolate the stimulus. Just like with the previous video of creating a slider, I'm going to make motion tracking on the x-axis. But then after I make the x-axis, I'm going to create y-axis motion tracking at an additional group level. So one more branch on the hierarchy here. So let's begin with x tracking. You can see there's no stimulus defined right here, but what I want to do is make a rectangular region that's tall and skinny. And I was kind of playing with the values already, and these look pretty good, but I just want to make sure that you see that rectangle. So I'm going to change these values and kind of scoot them through here. Minus 115 is the edge of my rectangle because stimulus coordinate systems are center based. So minus 115 will give me that left edge. I made the height the same height as my square here. Actually, it's 243, so let me bump it down to, I could make it taller or shorter, but I just want to make it match. So 243 here. And I want this to happen regardless, so undefined is 0, that's great. And I want to choose a variable called xtrack or ytrack. If I choose xtrack on the left, I want that to be 0, so I click define. And once again, the cool thing about stimulus is it's a center-based coordinate system, so I just remove the minus sign, keep it xtrack, enter 243, and click define. Now I could have entered 10, and that would only give us 10 possible coordinates across that space. But for the sake of this example, I wanted to create the ability to motion track on a per pixel level for a 243 pixel wide object. Okay, so just without doing anything else, if I come in down here and I actually type x and underscore track in the animation pane here, I'm not going to define anything. The reason I put it down there is just so we could watch the value in run mode, and you can see that xtrack is already working for us. Okay, so that would give us our x coordinate. And once again, just in case you didn't know where to look for there, we're watching this state field as I do this motion across this green square. You can see that animation state is changing because stimulus is affecting the value of xtrack just by stimulus. There's no graphical animation involved, nothing's moving on the screen, but we're tracking motion there with these enter events. And again, just a review from the slider example, the interpolated stimulus lesson, is that really what we've given it is a start point and end point for stimulus, not for animation, for stimulus. So by saying here you're 0, here you're 243 as an enter event, it went through and made 243 slices of enter events, so that every time we enter a new one of those interpolated sliced pieces of enter events, it increased the value of xtrack somewhere between 0 and 243, which it knows about at the beginning and end there. Okay, so that group is our x tracking. We could name this xtrack if we want, just to remind ourselves what this group is purposed for, but we don't have to do that. What we do have to do though is we have to group it one more time. The reason we're grouping it one more time is the xtrack is handling stimulus at this group level. This new group level is going to handle y tracking. If we do it at the same group level, your motion tracking is going to conflict with each other. So now let's go into stimulus and create the same thing but with y tracking. I just want to point out while we're here, and maybe double click find so it minimizes. I can also use the buttons here, but I just double clicked it to minimize the find pane so that our stimulus pane was a bit bigger. I did that because I want to show you that we can actually see the child stimuli on any selected object. So it's showing us the child group extract, but we can't edit it because it's at the child level. We can only edit the stimulus at our currently selected group, and that's exactly what we want to do. We want to now create, instead of tall skinny rectangles for X tracking, we want short fat rectangles for Y tracking. So step one is simply to reverse these numbers, 243 and 17 instead of 17 and 243, but you notice X, Y's, it's in the wrong place, so we'll put that as 0 and make this 115, actually minus 115. I want to start at the bottom for this example. Minus 115. So now we have a short and fat rectangle at the bottom. Instead of X track, we're now going to name this Y track. It is set to 0 already for us. That's nice. So we can click define. So now at this group level, not the child level, but at this group level, we've created a Y track. Okay. Make sure you don't have it selected, otherwise this will turn into redefine. You might overwrite what you want. We actually want to make it unselected so we can create a new one. And all this new one is going to be is removing the minus sign. Okay, and then changing the Y track value to 243, whoops, not 2463, but 243, and click define. Now we have, just like we had with X, we have a Y track 0 and 243. Alright, now I could go back to the animation pane and type in Y track, but at this point I think what I will do is actually bring in two readouts. And these are text IOs, just simple text IOs. They have no input. I guess they're text O's, they're just text outputs. And I'm just going to copy and paste two of these here, and maybe so they look a little prettier, go to the home ribbon and align their bottoms. Alright, and I'm just going to come into the animation pane and literally rename its integer, because we're going to be dealing with numbers here. I'll just rename its integer X track here. This is kind of just brute forcing the numbers to populate with the current value of X track and Y track. And then I'm going to change this to Y track so that when we're in run mode you can actually see that they populate with our coordinate system 0, 0 and 243, 243 and anything in between. Alright, so this is great because then if you were to get a left down event at any point in this motion tracking field, you could actually record the coordinate at which that happened and apply logic to that coordinate of a left down and a left up to do things such as gestures.